Well, good morning and good afternoon, everyone. Happy to see so many people here joining us for Beyond Compliance for February 2021. Today we got a great topic. We're talking with Dr. Acheson from the Acheson Group. Very happy to have him aboard, giving an update for North American manufacturers about COVID-19, the vaccine. So we're actually scheduled for about an hour today, and we'll be making good use of all of that. Anyone that's joining us maybe for the first time, Beyond Compliance is a monthly industry update for process manufacturers. The goal here is simple, just to bring you insights around the market that shape the way you grow our businesses and deliver quality products to customers and safeguard our brands, and all while being compliant with all the numerous regulations we share. My name is Aaron Bolshaw, the VP of Marketing for SafetyChain and the moderator today, and that's the sponsor. SafetyChain is the #1 plant management platform trusted by over 1,500 manufacturing facilities to improve yield, maximize productivity, and ensure compliance. And then, of course, our presenting sponsor, the Acheson Group, very good close friends of ours, global leaders in food safety and public health consulting. It's really helping companies deploy best practices to mitigate operational, reputational, and regulatory risk. I often say, I hope no one ever gets a recall, but if you do, you want these guys in your corner. With that, we're scheduled, like I said, for an hour. You're on mute. We can't hear you, but we do want to hear from you. So if you would, use your webinar console to submit questions through the presentation, and we'll save time at the end to get to as many as we can. So with that, I do want to introduce Dr. Acheson. Dr. Acheson has been with us a lot for FSMA Fridays, another webinar that we host, and you've got over 30 years experience, including the former Associate Commissioner of Foods at FDA, Chief Medical Officer at USDA Food Safety and Inspection Service, tons of other really great stuff. Dr. Acheson, welcome.
Thank you, Aaron. It's a great pleasure to be with you today to talk about vaccines, COVID vaccines. Clearly a very dynamic topic, changing constantly, and a lot of, I think, thirst for knowledge and understanding about what's going on. So hopefully over the next hour, we will satisfy some of that thirst and provide some new insights. The general structure. Sorry, go on.
I was looking at it's okay. I was looking at the calendar. It hasn't even been a year since Northern California first locked down. If you remember, I think the 5 counties around the Bay Area were some of the first to lock down across the country. And that was around March 12th, 2020, if memory serves me. And it serves me because that's my son's birthday. So, and here we are talking about vaccines, which is in itself quite amazing, right?
No, absolutely. When one thinks about the normal timeline to get a vaccine on the market, we're talking years, several years at best, and that's moving fast. So to your point, we've basically gone in less than 12 months from lockdown to vaccines going into people's arms. It's truly amazing how swiftly it has moved, and it just goes to show what science can do when it needs to. So absolutely. So what the general structure of what I'm going to discuss is a little bit just on vaccine basics. What are we trying to accomplish? And then sort of lead that into the different strategies for the vaccines for COVID-19 disease. Because there are a number of different strategies out there that the different manufacturers have used. We'll talk about safety, and we'll talk about efficacy, which basically how well do they work for some of the different vaccines, and the rollout strategy. And then sort of move into the last part of the conversation today will be other factors that we need to think about as the vaccines are literally coming out into the marketplace. So vaccine basics, what are we trying to accomplish with a vaccine? Clearly not a new concept. Vaccines have been around for decades, and past history has shown that they can be extremely effective in literally eradicating disease. The most, I think, significant example of that is the role that vaccines played to eradicate smallpox off the planet. There are other examples where vaccines have done an enormous amount to reduce illness and death globally. So vaccines basically are designed to contain either whole microbes that have somehow been inactivated or parts of a microbe that produce a disease. And the vaccine, once administered, is designed to imitate that disease, but obviously not actually cause the disease. So the concept is quite simple. When the human body is exposed to an infectious agent like the COVID pandemic virus, or like measles or other infectious diseases, the human body generates an immune reaction to that, which is designed to fight off that disease. And the vaccine concept is, well, let's show the human body the microbe before it causes the disease. And you do that in a way by presenting it in a way that is the immune system is going to see it as the real deal, but in fact it isn't. In a way, it sort of fools the immune system into generating a protective immune response against the disease, but obviously the goal here being not to actually cause the disease. And a successful vaccination program is then going to protect that person, the vaccinee, from the real disease when they get exposed to it. So the vaccine concept is simple. So how does one then approach creating vaccines for COVID? And as I mentioned just now, there are several different approaches that have been used. The basic structure of the virus that causes COVID-19 is shown on this slide, and its technical name is SARS-CoV-2. It is a version of the SARS virus. It's a coronavirus, and it structurally looks a little bit like the image on the screen, in which it's essentially a spherical structure, and inside that sphere is the genetic material that the virus needs to replicate itself. And on the surface of the sphere are little, what are called spike proteins, which on this slide are shown as the red structures. And you can see that there's different kinds of structures there. We've got E proteins, S proteins, M proteins. And these play a really important role. These spike proteins play a very important role in the virus attaching to the human cell. So if we go back a little bit, and when somebody gets exposed to the COVID-19 virus, somebody coughs on them, for example, who's infected, these virus particles get into your eyes, into your mouth, into your nose, or hopefully not if you're protecting yourself, but if they do, then these spike proteins bind onto the human cells. And that then results in this virus being internalized into the human cell. Once it's inside the human cell, the virus kind of takes over the machinery of the cell. It releases its genetic material, the genetic material from the virus, which then starts to create new copies of the virus. So the concept about this is, if we can create an immune response that prevents those spike proteins from working, then or from attaching, because essentially our immune system binds onto them and blocks them, then we've got a very good way to reduce the likelihood of infection. And that basic concept is what is behind a lot of the different kinds of COVID-19 vaccines. There are basically 4 different approaches to the vaccines, and they've all been used, and I'll touch on each one of them with specific examples in a minute. But the 4 different strategies for creating a vaccine are shown on this slide. The first is to use the whole virus. And the virus is attenuated in some way. It's treated so it doesn't actually cause the disease. So here we take a virus and you treat it either chemically or by heat or by whatever other mechanism. So you haven't fundamentally altered its structure, but you've basically killed it. So when you administer the whole virus to somebody, the immune system sees it as the real deal, but the virus is dead. The immune system still responds to that dead virus, but it doesn't cause the disease. The second strategy on the slide is that you take a piece of the virus and you purify it away. And the obvious example that's been used is that spike protein. So you don't use the whole virus, you use a piece of the virus. You take the spike protein itself, you purify it, you package it in a way that can then be injected. So the immune system sees just the spike protein. That's the second approach. The third approach is more complex. And here what you're doing is you're taking some of the genetic material from the actual COVID virus, and you are packaging that genetic material in a way that it can be delivered to human cells. And this is the basis of the two vaccines that are currently available in the United States, the Pfizer and Moderna vaccines. So what we're doing here is we're taking genetic material and we're converting it into something called messenger RNA, or mRNA for short. That messenger RNA is then packaged in a lipid envelope, that lipid envelope with the genetic material inside it is what is basically in the shot that you get in your arm, and I'll get to that in a bit more detail in just a second. One of the challenges with this approach is that messenger RNA is very unstable, and that's one of the reasons why these two vaccine candidates, Pfizer and Moderna, need to be stored at very cold temperatures in order to make sure that this genetic material lipid complex remains stable. So that's the third approach. The fourth approach, again, is an interesting one that has been used before. And in this situation, we're taking the same genetic material that we used in the third approach, but rather than packaging it in a fat lipid bundle, it's actually being put inside another virus. So you identify a virus that is harmless to humans. You essentially, through genetic manipulation, you put the messenger RNA, the message for the COVID spike proteins inside a harmless virus. So think of it a little bit like a Trojan horse for number 4, where you're delivering the Trojan horse, the genetic material inside this harmless virus then gets out into the muscle cells, and the muscle cells begin to make spike protein. So strategy 3 and strategy 4 are both ways to deliver message to the human muscle cells to allow them to make spike proteins. So those are the 4 different approaches. I want to take just a second to provide a bit more detail for the messenger RNA-based vaccine. And I'm doing this simply because these are the 2 vaccines that we have available to us today in the United States. So here we've got a little graphic, and the graphic there is showing an image of a person getting a shot into the muscle in the upper arm, which is where the vaccines are delivered. Inside that syringe are our lipid balls, our spheres, and the little squiggle inside that gray circle is designating the messenger RNA. So the syringe is full of these little particles of lipid with the messenger RNA inside them. Once the shot is delivered, moving over to the right-hand side of this slide, those lipid particles get inside the muscle cell. The messenger RNA, which is our blue structure, our blue squiggle there, is then translated by the muscle's own translation machinery. And the end result of that is new proteins are created. New spike proteins are created because the proteins that are created are driven by what's on that message, and that message carries the message to make spike proteins. And in our graphic on the right, the spike proteins are designated as the blue structures that move from the muscle cell itself out into the body. The immune system then sees these spike proteins as being foreign proteins and makes an immune response to those, so that when you get exposed to the real virus, you basically have an immune response already built in. So this is the approach that's being used for the 2 vaccines that we have available today. So let's dive into these 2 vaccines in a bit more detail. As I've mentioned, they're both messenger RNA based. They both have the FDA emergency use authorization. The Pfizer was the first to come online last December. Pfizer did a large international study. They looked at 44,000 people. They basically split them up roughly 50-50 between those that got vaccine and those that got placebo, which was also a shot but it didn't contain the messenger RNA. It was just an inactive shot. Those individuals are then followed, both the vaccinees and the placebo recipients. They're followed for a couple of months, and essentially determining how many of them get COVID-19 infection and how severe it is. And what they found over a course of a follow-up was that the vaccine had a 95% efficacy to prevent symptomatic COVID infection. It wasn't complete, it wasn't 100%. But the key message here is that it reduced the likelihood that you'd get it, and it reduced the severity of the disease. And that's an important part of this. The Pfizer vaccine study was done in individuals 16 years and older, so that's the nature of the approval from FDA is individuals 16 and older. As I mentioned earlier, it's inherently unstable, and it has to be stored for transportation at very cold temperatures, -94 Fahrenheit. The Moderna vaccine, similar study, roughly 30,000 individuals split into two groups, 15,000 each. 94% efficiency or efficacy in preventing COVID infection. It too reduced severity, it reduced likelihood of hospitalization, it reduced likelihood of mortality. Moderna's study was in 18-year-olds and above. It's a little more stable, but still has to be frozen. So bottom line from this slide is these vaccines work, and they work well. 95, 94% efficacy is good. Not 100%, but even those that got sick, the few that got sick, had a less severe illness than they probably would have had they not been vaccinated. Obviously, based on that, we say they work, but what about safety? Overall, these two vaccines are considered safe. If they weren't, they wouldn't have had approval for use by the FDA. We've come to recognize that there are local reactions at the time of injection, and I'll get onto those in just a second as to what those are and how long they last. There were very few serious reactions during the study, and the two studies that I've just talked about, there really weren't any statistical differences between the recipients of the vaccine and the placebo when it came to any serious reactions. Since the vaccine's been rolled out, I'm sure many of you who are aware, we have heard about acute allergic reactions in some people. Those are occurring at about the rate of 1 per 100,000 vaccinees. So they're rare, but when you get them, they're serious. And these allergic reactions are much like the same reaction that one would get from an acute exposure to peanuts if you were a peanut allergic. It's exactly the same thing going on, except that it's something in the vaccine that people are allergic to. And it's been difficult to predict who those allergic people are. It doesn't seem to track with prior allergies to, for example, foods. But it's because of this rare, but potentially serious, and 100% reversible allergic reaction that the recommendation is that the vaccine is done in a place, a venue, where the expertise and the drugs are available to reverse it should you need it. So it's kind of, you need an EpiPen or the equivalent to reverse the reaction. And that's one of the reasons why vaccinees generally have to wait a little bit. If you're going to get a reaction, it's usually within 15 minutes. But that's one thing that we have learned. Other than that, so far, we haven't seen any significant severe reactions from administration of either of these vaccines. As I mentioned earlier, you get side effects from the vaccine itself. And these are short-term, typically 24 to 48 hours. I've listed down there on the left the common side effects, some soreness, redness at the injection site, fatigue, headache, muscle aches, chills, some joint pain, fever. All of these should be anticipated in people who get the vaccine. As I say, they're usually gone within 24 to 48 hours. Over there on the right-hand side of the slide is a graphic, excuse me, is a graphic showing the difference between the Pfizer and the Moderna. And I know it's a little hard to read, but it basically tracks down that same list. And you can see there that roughly 80% of people get discomfort at the injection site, and it works down to 15% of people who get fever. So these side effects are present. We should anticipate them. In some people, maybe 10 or 15%, the side effects are severe enough to kind of keep you out of work, not long term, just for 24, 48 hours. And it's for that reason that one of the recommendations is that if you're working in a manufacturing facility and you have the opportunity to get people vaccinated, is that you stage it, you stagger it, because we must anticipate that a proportion of vaccinees are going to have some side effects, which might mean they need a day off just to get over it. So those are the two vaccines that are available in the US today. As you all know, this is likely to change. There's lots of other vaccines in the works. And I would suspect that some of the people on this call are either working for companies that have international connections or indeed are international companies. So I want to talk a little bit about some of the other vaccines that are out there. First one to touch on is the AstraZeneca vaccine. This was kind of number 3 in the pipeline. It was approved in the UK. It's not been submitted for approval here in the United States, so it's not available here. It's about 90% effective, but there are continued studies that are ongoing about how to optimize that. This AstraZeneca vaccine uses a modified chimpanzee adenovirus. So going back to the slide where I talked about the 4 different approaches, this is the one that I referred to as the Trojan horse. This is a one where what's been done is to put the spike protein genetic message inside a different virus, in this case, an adenovirus that's harmless to humans. And that's what's injected into the human as part of the shot. The human cells then make the COVID-19 proteins, specifically the spike proteins. The immune system sees those proteins and creates protective immunity. An advantage of the AstraZeneca vaccine over the 2 that we have here in the US is that it's much more stable. Essentially, it'll survive in the refrigerator for 6 months, as opposed to needing some of those very cold storage temps. So that's a logistic advantage. The next vaccine to talk about is the one made by Johnson & Johnson. This also uses an adenovirus. It's known as adenovirus 26. It's a different one from AstraZeneca. This is a human virus, but same principle. This has a single shot. All the other vaccines require 2 shots, sometimes 21 days apart, sometimes 28 days apart. It varies. This is a single shot, which obviously offers a huge advantage. In terms of does it work, overall, the studies have shown 66% effectiveness. So not quite as good as the Pfizer or the Moderna, but still pretty good. And the single shot is a huge advantage. Not much data yet on side effects. From what I've seen, nothing major of concern, but we'll learn more about that. It has the advantage, again, of refrigeration, temperature storage, and information has been submitted to the FDA for approval for this vaccine. And there's a meeting that's scheduled for February 26th, in which the FDA advisory board will review this material. And I think once that happens, we will know a lot more about the studies behind the J&J vaccine. But I think this will get approved. I don't see a reason why it won't, but we'll see. So this is an important one for us to stay up to date on, because it's likely to be the 3rd one that's available here in the US. There are others. Novobax vaccine. This is a vaccine that was created by a company on the East Coast. This uses the spike protein itself. So it's a different strategy. Purified spike protein, 2 shots, 21 days apart. So far, the studies have shown it works well, 89% effective. Not much information yet about side effects or other aspects of this, but it's out there and it's moving along, and we'll learn more about this as we go forward. There's a Russian vaccine, and this uses adenovirus again, so same strategy as the Johnson & Johnson and the AstraZeneca. This is a combination of two different adenoviruses, adeno 26 and adeno 5. There was a recent article published in the British medical journal Lancet about this vaccine, in which the Russians had studied some 21, almost 22,000 people. Most had got the vaccine, 16,000 got the vaccine, about 6,000 got placebo, 91.6% effective overall. 65% people got side effects, flu-like symptoms, much like we've seen with the Pfizer and the Moderna vaccines, with no serious adverse events attributed to this particular vaccine. This is an important one because it is being distributed globally. The Russian vaccine is being sold all over the world. So if you are an international company or have international connectivity, you're probably going to run across this one. The study that was done in Russia and published in Lancet certainly showed it was pretty effective, but it's obviously being used widely, and we'll continue to learn about it. A couple of others. China came to the market quickly with a vaccine known as Cynovac. This uses killed virus. So going back to that earlier slide of the 4 different strategies, this is a different one again. It's using killed virus. Not much information out there about this one yet, but there was a large study done in Brazil to show it was about 50% effective. So not particularly exciting in its effectiveness relative to the other vaccines that we've talked about, but nevertheless, it's being used pretty widely, obviously in Asia, particularly in China. And then finally, there is a vaccine that was created in India by a company called, it's known as Covaxin. It uses an attenuated virus. So the Chinese strategy and the Indian strategy is very similar. These are viruses that have been inactivated. This Indian vaccine, the Covaxin, has been rolled out in India. It's hard to get information about how effective it is and the level of side effects. The Indian government has warned individuals with allergies or underlying fevers or bleeding disorders to be careful about getting this vaccine. So we'll learn more about the Indian vaccine, I'm sure, in the coming weeks. And then there are at least 50 others under development. So there's a lot going on with vaccines in terms of ones that we have, Pfizer, Moderna, J&J we're likely to have soon, and then all these others that are being used in different parts of the world, and likely others that will come on the scene in the coming weeks. So as Aaron said, very dynamic situation, stuff's changing all the time. Brief comment on rollout strategy. The CDC have a group of individuals called the Advisory Committee on Immunization Strategies, or ACIP, and this group came out with the tiered rollout structure that we're all very familiar with, involving 1A, 1B, and 1C, where 1A are those that should get it first, healthcare personnel and long-term care, and so we work down. As we've all learned, the rollout strategy is being driven exclusively today at the state and local level, and every state has got their own way of doing it, their own way of signing up. Many have set different priorities. Some have focused on critical frontline essential workers. Some have focused only on age. It's kind of all over the place. So my advice there is, wherever you are located, or wherever your plants are located, or wherever your workforce is located, absolutely check in and track with what's going on at that local and state level, because it's all different and the processes are different. There's resources available on our website at achesongroup.com and on Centers for Disease Control website that will take you to individual states if you're having a struggle to find that. But generally, it's pretty readily available. But it is different in every different state. So it's important to check in on what's available in your local area. I want to move on and talk about COVID-19 variants. Obviously, the focus of our conversation today is vaccines, but variants play right into this. And a common question is, all right, so these vaccines were created against the original strain. Will they work against the variant strains that we keep hearing about? So What variants are we talking about? Well, there's quite a few out there, but there's a few that are talked about a lot. The UK variant, it's scientifically known as 501YV1, but it's often known in the media as B117. There's a South African variant, there's a Brazilian variant, there's a California variant, and there's a bunch of others. These variants generally are variants because there's a genetic mutation in the spike protein. The spike protein we've been talking about all along, which is that very important molecule which allows the virus to bind to your cells and allows the virus to get internalized. And it's the spike protein that we're trying to create an immune response against with these vaccines. So if the spike protein changes, will the immune response still work? It's a great question. The answer to that question is, so far, the vaccines seem to be working reasonably well. Generally, varies a bit. The vaccines aren't working quite as well against the variants as the original strain, but they still work well and still offer significant value. So what are we seeing here in the US in relation to the variants? Well, at the moment, most recent data is about 25% of the virus infections that are being sequenced are variant strains. So the majority is still the original. CDC predicts that by March, the UK variant 117 will be the predominant strain in the US. The numbers are definitely shifting that way, but we're not there yet. These strains are different. As I mentioned, the spike protein is where they differ, and they seem to result in increase in transmissibility. In other words, they appear to be more infectious. They appear to be able to spread more easily because these mutations in the spike protein, I think, allow, that's the hypothesis, they allow the virus to attach more easily to the human cell, and so they get inside more easily. There's been different opinions on whether the illness with these variants is any different. Some studies out of Europe have reported that they are more severe. Some have reported that they're not. So far, where I've landed is that I haven't seen convincing information to say that they are significantly more severe. Yes, they transmit more readily, but they don't appear to be more severe so far. And as I mentioned, the indications are that the vaccines work pretty well against these variants. One of the questions often pops up is, can you change the vaccine? Well, do we need to change the vaccine? And the answer is yes, because these processes that I talked about as to how they make these vaccines, it's relatively easy to change the nature of that messenger RNA. So it reflects the new spike proteins, not the old ones. This obviously raises other questions that we may get into in Q&A about, well, does that mean we're going to have lots of shots and boosters? And right now, that's not clear. The key message today is that the vaccines that we've got are working against the strains that we're dealing with, and that's where we need to focus, is exactly that, and not worry too much about what's coming down the road in terms of what we're going to do today. So, some key points to reiterate: the vaccine, Pfizer, Moderna, that we know a lot about, and these others are reducing the severity of the disease. They're reducing hospitalizations, they're reducing death. You don't get 100% protection. Efficacy of 95% means some people will get it. Yes, that's true. But the level of disease they get seems to be much, much less. We don't have a lot of information about whether the vaccine reduces actual transmission of the virus. I personally believe that it will, because vaccines usually do. There's some very early studies that have come out of Europe saying, yes, it looks like transmission is reduced, but we don't know for sure about that. And it's for that reason that we're continuing with the most important preventive controls that we've been employing since February last year. We need to continue with our preventive strategies for two reasons. One is that there's at most 3 or 4% of Americans have received vaccines, so we're still having to focus on our conventional ways of preventing spread. masks, social distancing, hand washing, contact surface cleaning, etc. The second is because we don't know for sure that the vaccine reduces transmission, we have to advise people, even though they've had a vaccine, that they have to continue with our standard preventive strategies. Because of this rare allergic reaction I talked about, the recommendation is that the vaccines are administered in facilities where you can address that should it happen. It's rare, 1 in 100,000, but as I said, when you get it, it's severe and it's reversible. I've talked a little about the variants and how that's going to continue to evolve our strategies and our thinking, because again, as we've said more than once today, that the COVID-19 story continues to evolve and change, and we are all trying to stay current and how to manage it. One of the things to think about, most importantly, is to develop your strategy for your workforce around what to do. Different companies have to make their own minds up about what to do, but one way that I think is helpful to think about this is there's different strategies. Number one, I think it's important for everybody to educate their workforce about the vaccine. OSHA is certainly put that in their most recent guidance. I think it makes a lot of sense, providing information to the workforce about where to go, how to get it, giving them information about some of the links, how to sign up for it. That is a minimum, I believe. Beyond that, you have to determine your strategy. And I've broken this down into 4 levels. The highest level is that you mandate that there'll be a vaccine. The next level is you incentivize. The third level is that you encourage or you recommend people to get the vaccine. And the fourth level is that you simply facilitate people to get the vaccine. And while there's obviously overlap between some of these, I think this is an important structure to help think through, where am I going to go? Where am I going to go as a company? Am I going to mandate or am I just going to facilitate? And where do you land? And obviously this is a complex conversation that involves leadership, it involves legal, it involves lots of other levels to see where you land as a company. But you need to land somewhere, because leaving it just floating is not desirable. As I mentioned earlier, in terms of a strategy, is consider staggered administration of the vaccine in your facility, simply because we anticipate that probably 15 or 20% of the workforce is going to get the vaccine and they're not going to feel like working because they feel like they've got flu. Those symptoms go away pretty quick, but they are nevertheless significant while you've actually got them because you don't feel so good. So that's some thoughts. Aaron, I think you've got a couple extra other thoughts to add to this before we can summarize.
Yeah, I just want to go back to what you're saying, Dr. Acheson, about preventive strategies. It is about that preventative nature. This wouldn't quite be beyond compliance if we didn't touch on some of the compliance factors here. We still are responsible for preventing the spread in our manufacturing facilities, right? We've gone through a lot this last year, so I just wanted to recap some of the things. First of all, there are CDC resources available. Anyone on the phone live today or watching later on, we'll get a link to this resource to you all, so you've got that as well. But it just comes down to the basics, right, Dr. Acheson? Social distancing, making sure you're 6 feet apart, make sure you've got the PPE available, always on, and you're checking that. Disinfecting shared spaces, making sure you're washing your hands for 20 seconds often. And there's also very interesting guidance around airflows and fans in your facilities. If you've got multiple workers on a line, which many of us do, right? Let's just face it. If there's a airflow going over those areas, you've got to be able to account for that. So we've worked with one of our customers at SafetyChain, a $3 billion food service company, and they've done extremely well through COVID mitigation practices using the software, and they've been able to do over 73,000 audits in 6 months. This covers all of this. They're auditing social distancing, making sure everyone's in the right spot, PPE mandates, and hand washing. So there are ways that you can make this easier on yourself. And I just want to take a second, Dr. Acheson, and ask everyone to, I like developing data points on some of these things. I'd like to know, and I'm going to ask a question really quick about what you all, if you would, I'm going to launch this poll. What best describes your COVID-19 protocols and internal compliance audits? The poll will pop up in front of you here in just a second. And just take a second. We won't share your name. This doesn't attach to anybody's names. So please be honest, right? So, select one or more. You can select as many as you want here, okay? So do you have documented written guidelines that are auditable? Can you look at something and say, hey, yeah, we're following this? Do you have periodic training for employee health and safety, the PPE, other risk mitigations? Are you talking to your employees? Do you do daily compliance checks across all those guidelines and protocols, or maybe even more, right? Do you have what's kind of the pinnacle of this, a dashboard level view of data and indicating areas of concern? If there's some places or some facilities or some lines that are having trouble, sometimes, guys, we know this is just a aspect of the way your building was built, right? So, or do you not have any of these protocols? So I'm going to take another second. About 50% of us have voted. And I will share one last thing about the customer that we were talking about. The visibility on this goes up and down the organization. The CEO of this company called the director of compliance and safety and said, thanks, because he was able to see exactly what was going on. He had that confidence, that calmness that goes with understanding, hey, we've got everything we need in order. And that's really important, right? Just that confidence. So I'm going to share the poll now. It should come up in just a second, and then we'll get back into the presentation, Dr. Acheson. But this is really encouraging, right? We've got a lot of people with documented guidelines. It's auditable. We've had a lot of time to figure this out, and boy, did we have to just figure this out, right? Great on training. Training and communication continues to be just one of these primary responsibilities for management. Got to make sure that people understand what's good, what's right, what's going on, and what we expect of them. Daily compliance checks goes down a little bit. That's okay. Some people aren't doing daily. They can do weekly or less periodic. Here's one that's interesting, though. Dashboard level view of data indicating areas of concern. That might be something, if you're interested in, that might be something worth looking at. Because again, if you're using paper pens, doing these checks, absolutely fine. That's all auditable. I get it. But boy, if you need to create an audit on the fly, it can be a pain going back and going and finding all that data on paper. So, and then just 1% don't have any of the protocols in our strategy. So we're here to help any way we can. So with that, I'm going to come back over here. We'll start this up again. And Dr. Acheson, why don't you take us through just kind of the summary, and then I see we've got a few questions. So I'm going to start preparing some of those for you.
No, it sounds great. And interesting poll numbers. That, to your point, it's great to see so many people have got good strategies in place. In some of what we discussed over the last 40 minutes or so, the current vaccines that we got in the US work. As I said, they're showing this high level of efficacy, 94, 95%. So that's great news that these vaccines are working, and I want to emphasize that they are reducing the severity of the disease. So even if you get COVID, all the indicators are that it will be less severe, less likely to make you seriously ill, obviously less likely to lead to hospitalization or more severe outcome. This question of whether the vaccine impacts viral transmission, I've touched on that. Because we don't know, that's why we're recommending people to continue to wear the masks and socially distance and doing all of those controls. We will know in time, but for now, we're having to be, and I think wisely, very, very careful. We've got rollout plans at state and local levels, and as I've recommended, do check in with what's going on in your local jurisdiction. The importance of continuing with the current controls, I can't overemphasize that. When we link that concept of continuing with the current controls, but we don't know for sure that the vaccines reduce transmission, we've got the impact of the new COVID variants. All of this sort of plays into thinking, pulling out the crystal ball one more time and trying to figure out what's going to happen and where are we going to head. Looking at the data across every state. And as some of you know, we do this every week at TAG. We're looking through our risk matrix, every state across the country. As of today's data, we've got every state headed in the right direction. There's been a few bumps in the last week, but generally everywhere's headed in the right direction. Transmission rates are dropping, numbers are dropping. That's a fantastic trajectory for us to be on, but what can turn it upside down? First of all, that we relax on our basic controls too quick. We cannot afford to do that. We're all sick and tired of face masks and social distancing and all that kind of stuff, but we've got to keep going with that. We don't have enough people vaccinated yet for it to have a significant impact. We have got this wild card of the variants and the fact that they appear to transmit more easily. So far, we've navigated that very well in the US. Other countries have not fared so well with that, particularly examples like the United Kingdom. So the overall strategy here is get vaccinated if you can, understand the issues. Obviously, there's individuals who have questions, they have concerns about the vaccine, they're hesitant to get the vaccine. And my recommendation there is go and talk to your healthcare provider. Make it personal. Go say, here's what I'm worried about. And learn about whether the vaccine is right for you. And the final point in the summary is creating these communication strategies, creating your internal strategy wherever you are in the manufacturing, processing, growing space, food service, retail, it doesn't matter. You need a strategy as to what you're going to do around education and around that variability between mandate at one end and facilitate at the other, and figuring out just exactly what path you're going to tread. So with that, Aaron, I think that pretty much covers what we plan to discuss. I know we've got a few minutes for some questions, so hopefully we can dive into a few.
Yeah, we sure do. So thanks for that, Dr. Acheson. Again, it's just covering the basics, but boy, this is incredible, and we're very fortunate to have such a strong partner with the Acheson Group and yourself. So got a couple of questions coming in. So right off the top, I've got Sarah and Lisa. They've got similar questions, so I'm going to kind of pose them in a package to you. Are other vaccines being developed for the new strains? And if so, will those new strains lead to ongoing, like maybe those booster shots or annual shots of some nature? Can you kind of take a little longer look ahead?
Yeah, the vaccines that are on the marketplace today are principally designed against the original strains. And as I mentioned, they are working fairly well against the variants that we're seeing today. So definitely the pros of getting vaccinated to protect you are still there, even for the variants. My information is that some of these companies that are making vaccines are already reformulating and figuring out exactly what they need to do to manage the new variants. Time will tell where this goes. Are we going to need annual COVID vaccines like we have flu? I don't know. It's certainly a possibility. Are we going to need a booster shot because new variants have come along and we're all susceptible to them? Don't know. It's certainly a possibility, but the vaccine manufacturers are planning for that and altering the design of the vaccines accordingly. I think one final thought on that, Aaron, is that one thing we've learned is that this vaccine works against what we've got in the marketplace, so to speak, today, the viruses that are around. We've also learned that the virus changes. It's changed a lot, and that's what these biological agents do. They change, and I would suspect that the days of change are not behind us. The virus will continue to evolve. It will continue to change. I hope it'll change in a way that takes it out of circulation and not make it more virulent. But again, we've got to be nimble. And the good news, the manufacturers of these technologies can be nimble, and they can change pretty quick if they need.
Yeah, absolutely. The agility here is just amazing, but we got to stay focused. So great. Thanks for those questions. A few more here. If an individual, I thought this was interesting, if an individual develops side effects from the vaccine, this is from Tim, do they need to quarantine like 10 days, or like if they're experiencing symptoms without the vaccine? What's the word there?
Yeah, the current advice for individuals is that whether you've had the vaccine or not, if you develop COVID type symptoms, so fever, chills, muscle aches, headache, then today you should treat it like it's a COVID infection. And that means that if you've been vaccinated and you get these side effects, you need to stay out until they've resolved. Because we don't know, unless you get tested, whether you've simply got a reaction to the vaccine or whether you've got COVID, because the overlap in the symptoms is quite a lot. So we're maintaining the mantra of, if in doubt, then assume it's COVID and follow that track in order to be safe. And the rationale behind that is because we can't necessarily tell the difference without a test. So certainly if somebody's in that bucket and they get a test, particularly if it's an accurate PCR test and it's negative, then I'd feel confident that it's not COVID, it's a side effect from the vaccine, and you'd be okay to come back. But we need to be careful, and it really, Aaron, it goes back to this notion that as a country, we're doing well. And our biggest risk is that we open up and do things too fast. We say, oh, the vaccine's here, we can all throw our masks away and we can just, even though we feel sick, we can still go to work. No, we got to sort of hold the line on that.
Yeah.
So at this point, better to be cautious, better safe than sorry, as they say.
Yeah, good, always good advice. So we've got an interesting question here, sort of about the manufacturing side. So Joe asked, he'd like your thoughts, Dr. Acheson, on if you think states will eventually offer shots on site at like the factories and manufacturing facilities for essential workplaces. His note would just simply says this would prevent staggered administration, but would help ensure higher rate of vaccination. Any opinion there?
So far, I mean, it's a great question, and I mean that's the model that we use for influenza. It's a great question, and so far there's no commercial entities that I know that are offering it. But the question was around will states offer it? I don't know that of any that are. I mean, the model today is you go to them, they don't come to you. And part of that is perhaps based on ensuring that you've got the appropriate facilities to manage one of these very rare allergic reactions. I see no inherent problem with setting that up in a break room at a plant somewhere, a manufacturing facility. But we need to make sure we do it right, and we need to ensure that we're prepared for the unlikely eventuality of an acute allergic reaction. But so far, that's not been an option. As vaccines become more available, and certainly the indicators are that in the next month or 6 weeks, we will have a lot more vaccines. I know Pfizer have doubled their production rate. So we may wind up with that happening. And certainly, I think manufacturers need to make sure that if they are offering the vaccine on site, they've had a conversation with the entity that's offering the vaccine and saying, do you have the infrastructure to make sure that if we get one of these unexpected allergic reactions, you can deal with it? Because you certainly do not want the liability of that landing on your shoulders. Yeah,
for sure. Well, we got an interesting question kind of on the follow-up of that, Dr. Acheson, from Anne. She says, not a question. They have partnered with their local county health to facilitate a clinic on site. So follow up to that is, hey, this might require a call or two. Maybe there's something that you can do, but I think I'm backing up what you're seeing, Dr. Acheson. This is definitely a you come to us strategy, mostly because of the supply side. The supply is limited, and so you're trying to drive it through those tiers, right, in an orderly fashion, so that the right people are getting it in the right order. So, but that's fantastic, Anne. I appreciate.
Good comment.
Yeah, thanks, Anne, for saying that. I appreciate that. So one person said, I'm sorry I missed the information, but is manufacturing facility deemed essential workers eligible for the vaccine? Would you take us through, Dr. Acheson, just one more time? Like, this is very dependent on your state and the tiers that they set out. Will you just kind of recap that one more time for everyone?
Absolutely, yeah. The basic message here is that each state has set their own criteria for priorities. So if you've got a question about what's the priority in your state, then go talk to the state, check their website. Most of them have got those priorities laid out pretty clearly on the website, as well as the process whereby they're going to either reach out to those that are designated as high risk, or a process whereby you can sign up. Some states I know have sort of ignored the critical infrastructure and have gone straight into age as the criteria, irrespective of what you do and where you do it, or underlying conditions. So they focused more on who are the people, if they get it, are likely to have a bad outcome. That's been the strategy. Others have sort of leveraged a little bit the rollout strategy that we talked about. As you know, they've done healthcare workers and long-term care, and then after that, they've gone into the critical infrastructure. Again, state by state. So, message there is absolutely, check with your local state and use those resources to find out what it is that they're doing, and they're changing. I mean, that's the other factor. Is the strategy today probably won't be the same 2 weeks from now. And the reason is, as you alluded to, Aaron, is because vaccine supply is constantly increasing. So I mean, a lot of the states have been looking for ways to optimize the use of the vaccines that they have to reduce hospitalizations and mortality, which is a totally reasonable thing to go. As those supplies expand and they feel they've dealt with that, then I think they will embark more on critical infrastructure people who, by definition, are probably younger and more healthy. And so for that perspective, are less likely to have a severe disease or a bad outcome.
Yeah, good. Well, on that, someone else has an interesting question. I personally have looked for this information too. Wondered if you had a resource, Dr. Acheson. Is there any updates on the supply side of the vaccine? Are Pfizer and Moderna publishing any data related to the production and their supply in any way?
I don't know the answer to that, and I don't have a resource to refer to other than the general media, in which, my observation is that Pfizer has made public announcements that they have doubled their vaccine production, or they've doubled it in so much they've shortened their time for production from 120 days to 60 days, and as such have doubled it. I mean, that's public information. I picked that up off the media, but I haven't seen a resource where those are tracking daily production, right?
Okay. All right. And we've got time for just one more, Dr. Acheson. So this is an interesting one. So you can dodge this by giving your opinion, because this could get into sort of the legal side of the equation, and we don't want to pose any legal views here at Beyond Compliance. So Juan asks very simply, can you mandate the vaccine to employees, or is it just do you have to hold the line at recommendation?
Caveat, I am not an attorney, and so this is not a legal opinion, but my understanding is that OSHA has cleared the way to allow for mandatory vaccines for under certain situations. I'm not an OSHA expert. I'm certainly not an attorney in this space, and so it's important to look at the small print. But fundamentally, there is a window for certain people to mandate. Yes, is my understanding.
Got it. All right. Well, that brings us to the end of the presentation. We do have a lot more resources. Please check out SafetyChain.com. Please also go check out the Acheson Group. Brand new website, looks great. Lots of resources there. Specific COVID-19 resource in the very upper right of their website. And join us again next time. Beyond Compliance, we're going to continue to do these types of updates, and we'll also be continuing these tile updates on the FSMA Friday side as well. So with that, Dr. Acheson, again, as always, a pleasure working alongside of you, and I hope you stay well and you're doing well in the business world, and making sure people are staying safe and keeping their brands propped up the right way, okay?
Appreciate it, Aaron. No, thank you to inviting me to be part of this, and thank you to everybody who joined us, and some great questions, and hopefully the information was helpful.
Absolutely. All right, that brings us to the end today. Everyone, thank you so much for joining us. We'll see you next time.
Thank you.